All right, so here we go. We're going to go back to number 5. Number 5 is a really, really weird way to write absolute values. So one of the first things that we're going to do is, hang on, I have lost my pen. Found it. All right. So if I factor this thing, what I see is I have the square root of two numbers that multiply to 16 that add up to -8 are -4 and -4, which gives me the square root of x minus 4 squared. Now remember, that can be positive or negative. So what you've actually got is either a negative x minus 4, because you took the square root, or you've got a positive x minus 4. So when I take this one, he'll be a negative x plus 4. And when I take this one, he'll be a positive x minus 4. So when you take the derivative, this one's derivative is -1. When I take this one's derivative, his derivative is positive 1. So now the question is, this says find the derivative of g. Hang on, so we're not confused. Find the derivative of g, and you got a couple little boxes here. Well, if x is bigger than what? So if you remember how to shift graphs, what this means is you're doing a horizontal translation to the right 4 units. So I'm going to go if x is bigger than 4, and that's where I got the 4 from. If x is bigger than 4, then my graph is going to be going up. So he looks like this. Okay? It's just a really weird way to write absolute value. All right, so if x is bigger than 4, he'll have a positive slope. If x is less than 4, he'll have a negative slope. So that's number 5. And then I think what we did, hang on, I gotta look. Did I skip anything else? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've lost 10. Hang on, well hopefully I didn't need to go back. All right, oh look, there it is. All right, so you can do this one and you can do this one, which means now we're at some trig stuff, which is fine. It's no big deal. The difference is what's on the inside. So remember, the argument of a trig function is on the inside. So if I look at this, the derivative of the inside is 1. So I don't need to use chain rule. So this is going to be, what's the derivative of sine? It is cosine. And then it says, would you please evaluate that tangent at the origin, which means I need the point 0, 0, or an x value of 0. So find the slope of the tangent line. Well, this is the formula for slope of a tangent line. So if I evaluate the cosine of 0, I'm going to get a value of 1. So the slope of this line right here is a 1. So now let's look at this one. What I have is the sine of 4x. Well, what's my inside? Oh, my inside is 4x, and his derivative is 4. So I have to use chain rule on this one. So take your bigger picture first, just like what we've been doing. Do I know what the derivative of sine is? I do. It is cosine of what's sitting there times the derivative of the inside. So the derivative of 4x is 4. And now I have what is the derivative evaluated at 0. So I have 4 times the cosine of 0, which is going to be 4 times 1, which is 4, which is going to take me to the next step where I'm going to generalize some more. And so I have, can I make a generalization? Well, if I have the slope of sine x and the derivative was 1, and then I had 4x and the derivative evaluated at the origin was 4, well then what's going to be my value here? It's just going to be a. And so now we can do the rest of these trig functions. So I've got the cosine of 2x. Well, what's the derivative of cosine? The derivative of cosine is negative sine 2x. But what's the derivative of the inside? It's a 2. So that's your derivative. So we're just doing chain rule. So on 14, find the derivative of the trig function. Do I know how to take the derivative of tangent? And again, this is just one term. So derivative of tangent is secant squared. So I have 3 secant squared of 2x times the derivative of the inside, which is 2. So now I've got 6 secant squared of 2x. And then this one gets kind of fun because you got some insides going on here. So I know what sine is. So what's the derivative of sine? The derivative of sine is cosine. And I'm going to write everything that way. Okay? But I'm not done yet because I need to do it times the derivative of the inside. Well, do I know what the derivative of pi x quantity raised to the 9th power? Remember, pi is just a number. Don't let them freak you out. So this is going to be chain rule again. So I'm going to drop my exponent out front, which is going to be 9 times what's sitting there, and drop my exponent by 1. And then I got to do times the inside of that. So the derivative of pi x is just pi. So you actually have a chain rule going on like 3 times. So you have the original problem, the derivative of the argument, and the derivative of the inside of the argument. And so he gets a little bit confusing. So if you see something like that, sometimes you can work from the inside out. So do I know what the derivative of pi x is? It's pi. And then move out. Do I know what the derivative of 9 pi x is? It is 9 to the 8th. So I've done all that. Well, now do I know what the derivative of sine is? It's cosine of what's sitting there. And so that's another way to do it. I don't care which way you do it, but it's hard to see what's on the inside, so you need to practice on that one. All right, so let's look at 16. Hang on. I've lost my papers. All right, so here's another one. The question is, what's being raised to the 9th power? So on this one, just the argument was being raised to the 9th. On this one, the entire cosine is being raised to the 9th. So what you would normally, this is how you would enter it in your calculator. What you would normally see that as is cosine to the 9th of 8 theta. Okay, so what's being raised to the 9th power here? The entire trig function. Whereas what was being raised to the 9th power here? Only the argument, which is just the angle measure. So be careful on what's being raised. All right, so I'm going to do this 2 different ways. I can drop this out front, so your bigger picture is going to be 9 times what's sitting there. Drop your exponent by 1. Times the derivative of the inside. So what's the derivative of cosine? It is negative sine. And then go inside again. What's the derivative of the inside? It's 8. And so, well, I'm running out of room here. So times 8. So that would be a negative 72. What happens if you work from the inside out? So what's the derivative of the very inside? He's an 8. Okay. What's the derivative of cosine? It's a negative sine. And then what's the derivative of something to the 9th power? It is 9 times what's sitting there raised to the 8th power. So you get the same answer, it's just in a little bit different order. Okay, so this one, secant is being raised to the 7th. So you're going to have to drop your exponent out front. So 28, secant to the 6th. And then times the derivative of the inside. So remember, you're going to have to take the derivative of secant and then the derivative of him. Okay? Find the slope of the graph of the function at the, so this one is not done. You have to finish that one. That says finish. All right, find the slope of the graph. Hang on, how much time do I have? All right. At the function of the given point. So remember, this is going to get messy. What we have here is a 3x to the 3rd plus a 4x raised to the 1/5 power. So I'm going to take a derivative. I have to use chain rule. So I'm going to drop my 1/5 out front. Times what's sitting there. Raised to the negative 4/5 times the derivative of the inside, which is going to be a 9x squared plus 4. Okay? So that is your formula for slope for any point on the curve. What you need to do is shove a 2 in that thing. So once you shove a 2 into this, you'll know the value of the slope of this graph at 2, 2. All right, we got a couple more. So it says determine the points on the interval of one lap of the unit circle where I've got a horizontal tangent line. So here's the question. What are we finding when we take a derivative? We're finding the formula for slope. Well, what's the value of the slope of a horizontal line? It's 0. So I'm going to take a derivative and set it equal to 0. Okay, so what's the derivative of 14 cosine x? That is one term. The derivative of the inside is 1. So I just need to take a derivative and set it equal to 0. So what's the derivative of cosine? It's negative sine, and 14 comes along for the ride. Okay, this one, the inside is a 2x. So I'm going to have to use chain rule. So what's the derivative of 7 sine 2x? The 7's coming along for the ride. So the derivative of sine is cosine times the derivative of the inside will be a 2 times that 7 is 14. So set that equal to 0. Now the question is going to be, how do you handle this thing? Because that's a 2x and you need a 1x. You've got to have your arguments match. So look at that handout I gave you and look at double angle formulas. And you'll find out that you can swap out cosine 2x for something with sine squareds and 1s. And then you can factor and go from there. Then you can always email me if you have questions. All right, so find the second derivative. I have 2 minutes. Find the second derivative of the function. So the derivative of the inside is not 1. Okay, so I'm going to drop my 4 out front. Raised to the third, and then times the derivative of the inside. So the derivative of the inside is a negative 5. This is one of those cases where I want to clean it up because I've got to take a second derivative. So this thing cleaned up is a negative 100, 1 minus 5x to the third. That's your first derivative. Now I'm going to do it again. Drop your exponent out front. 1 minus 5x squared times the derivative of the inside is a negative 5, which is going to give me a 1500, which is fairly large. 1 minus 5x squared. And that is your answer. All right, so you should have a decent understanding of chain rule. And I know some of those are kind of issues, so I can address those when I see you next time, which hopefully will be tomorrow, but for sure on Friday.